Welcome, students. Welcome. Today I am going to discuss Dijkstra's algorithm, which is a technique under greedy method. It is also known as single source shortest path. I'm going to explain you the lab program. So for that, we will see the theory part, which we have already discussed in class. Okay. So for this, the algorithm goes like this. Algorithm single short path or single source shortest path. You're going to pass four parameters: p, cost, dist, and n. N is the total number of vertices. Cost is an adjacency matrix. Okay, it is n is a square matrix. So cost would be of the size 1 to n, comma 1 to n. Okay, and then given the graph, it can be represented by the cost matrix. Dist is a set that stores the shortest path from source vertex, okay, p to any other vertex in the graph. Mean to say, p is the source vertex. Dist will hold the distance from p to the other vertices. And S stores all visited vertices of the graph. Initially, it is a Boolean array. Okay, so none of the vertices are visited. Now, what is the logic? So, first I loop, it will do the initialization. For I equal to 1 to n, do S of I is 0. Okay, and cost of p comma j is stored in distance. So, sorry, cost of p comma I is stored in distance. Now, S of p is the source vertex. So, the first vertex, we are going to make it as 1. Okay, initially in S array, all the entries are 0. So, to start with, the first vertex, which is the source vertex, we are going to make it as 1. Okay, and we are going to put that source vertex in p array, S of p. Okay, that is 1. And initially, in that distance array, this p is the source vertex. We are going to store 0. Okay, and then the val we are going to run from 2. The first vertex, source vertex, we have made it as 1, and we are going to run the loop from 2 to n minus 2 do. So here what we have to do, we have to take the distance of, so from source vertex we have to take the distance to all the other vertices. So obtain n minus 1 path from p. Okay, choose q from the vertices that are not visited and with minimum distance. Okay, so we have to choose the next vertex which is not visited, and then we will have to see the distance, whether it is the minimum distance. So min of distance of I, we are going to put it in distance of q. Then since we have taken that q, we are going to set that S of q as 1. Okay, initially we had put everything as 0. As and when we choose a vertex, so that entry we are going to make it as 1 here. Okay, now the core logic comes here. For all node R adjacent to Q with S of R equal to 0, do. So for all the nodes, what we are going to do, if dist of R greater than distance of Q plus cost of PQ, then distance of R is going to get distance of Q plus distance of P to Q. Okay, I'll just explain you with a example. That is, distance of R, if it is greater than the distance of Q and cost of PQ, then that value is stored in, whichever is the lesser value, that will be stored in the distance array. Okay, and coming to the analysis, we have seen there were two loops. Okay, first for loop, it takes big O of n times. The second for loop, it takes again big O of n times. So single source shortest path would take big O of n square square time. So the complexity of this is big of n square. Now let's see how to solve a problem. Okay. Okay. Now using greedy method, trace the following graph to get the shortest path from a vertex to all the other vertices. The same graph I have taken in my lab program also. So before we go to the program, we will understand how to apply that algorithm which we have seen. Okay, so here you are going to have three entries. One is selected three vertices and then distance towards the other vertices, path shown in the graph. Okay, so we will see how to solve this. Yeah, for this graph, the source vertex is A. Okay, this is the source vertex. Now, from vertex A, I have to find the shortest distance to all other vertices. So, from A, what I do, first I write a cost matrix. Okay, it will be a 5 cross 5 matrix. If there is a direct edge, then I mention the cost, that is the edge weight as the cost. If there is no direct edge, I mention by infinity. Okay, so I'm going to maintain infinity if at all there is no direct edge from one node to the other node. So now from now, see, I'll tell you an example. A to B, the cost is 3. A to D, the cost is 7. What about A to C? From A to C, there is no direct edge. So I'll mention that as infinity. Okay, and then A to E. A to E, see, there is no direct edge from A to E. So I mention that as infinity. Fine. So as and when I find a, path, I will just go on adding the values. To start with, let me take vertex A. So from vertex A to B, what is the cost? It is 3. So A to B, I choose A to B is 3 has been, now B is been added to the array. Okay, B is been added to the P array. That entry we will make it as 1. And what is the distance from A to B? A comma B is 3. Okay, now what is the next value which I can find? I know this A to B is known to me. So can I find A to D? A to D, if at all I see the direct path A to D, the value is 7 or the cost is 7. But at the same time, if I go through A to B, B to D, it will be 3 plus 2, which is 5. Right? So this is how we are going to consider this algorithm. That is, we will go from A to B, B to D, it would be 5. Okay, so now A to D is 5. What about A to C? From A to C, it would be 3 plus 4, which is 7. As of now, in the second iteration, what about A to E? A to E, I don't have a path. So I mention that as infinity. Okay. So come to the next iteration. So A to B, B to C, which I showed you already. So A to B, B to C, it would be 3 plus 4, which is 7. So A to C, it would be 7. What about A to E? How can I go from A to E? You can see it. A to E would be A to E. If you go through D, it is 7 plus 4, which is 11. But at the same time, A to B, B to D. So 3 plus 2, which is 5. 5 plus 4 is 9. Okay, so you had other options. You could have gone from A to B, B to C, C to E. The value will be more. It is no more the shortest distance. So it is A to B, B to D, D to E. So that is the path we are going to take. 3 plus 2 is 5, 5 plus 4 is 9. So A to E, okay, the cost is 9. Now, yes, this is what we are going to see. A to E, the cost is 9. A to B, B to D, D to E, the cost is 9. This is how the algorithm works. Now we will have to conclude this. How do we conclude? So the shortest path from vertex A to all the remaining vertices. A to B, we have seen the path length is 1. Okay, see, A to B, we have a direct path of length 1. So A to D, how will you go? A to B, B to D, A to D. So for going from A to D, it is A to B, B to D. Next, if you have to go to A to C, it is A to B, B to C. So A to B, B to C, it is 3 plus 4, which is 7. Now A to E, we will go from A to B, B to D, D to E. The path length is 9. We'll see how we go. A to B, A to B, B to D. So 3 plus 2 is 5. D to E. So it is 4. Totally it is path length is 9. This is how we trace this algorithm. Now we'll see how to write the program for this, how the program is written. So yes, this is the Java program. The manual is already shared with you. So initially you accept, come to public static void main. Here first you accept the number of vertices, which is n, and then you accept the adjacency matrix. Enter the adjacency matrix. You are going to take the adjacency matrix. Then you will input the source vertex. Okay. So source vertex is SRC. After that, you invoke this Dijkstra's function, and then to start with, we are going to make source minus 1. Initially, we will put, if it is equal to I, we will continue, because initially it is 1 minus 1 would be 0. Okay, we are not considering that first vertex, so we will continue. And from the next vertex and onwards, this is going to work. This is the initialization code, and we are going to output the shortest distance. Here we are going to invoke Dijkstra. Okay, so let's see where the control goes. We are going to Dijkstra's algorithm. Now, yes, this is the Dijkstra's. We have done the variable declarations, and this is the initialization part. Okay, which I showed you in the algorithm. Dist of I, that is adjacence, adjacency matrix, adjacence of source minus 1 comma I. In the loop, we are going to initialize all this to dist of I, and we have seen that we had the array, visited array. Initially it will be false. As and when you visit a vertex, we will make it as true. So for the first time, we take the source vertex. So source minus 1, we will set it as true. Okay. And here we are going to check for the value. That is, for we are going to run 2 for loops again. Okay. If not visited, and if the distance is less than the minimum distance. Okay. That is, we are going to check if the node should be not visited, and if the distance is less than the minimum distance, j we will put it in unvisited, and distance of j we will put in the minimum distance. That is, if the present distance is less than the current minimum distance, we are going to put the new value in the minimum distance. Okay, and then once we take the new value, we will make this unvisited, this is visited of this as true. We are going to set it as true. This is the core logic which I explained. That is, we are going to run a for loop, v equal to 0, v less than n, v plus plus. If not visited of v, and distance of unvisited plus this. Okay, if it is less than distance of v, then we are going to assign the sum as I showed you. Okay, we are going to assign the sum to the new distance, dist of unvisited plus adj of unvisited of v, we are going to put it in the distance. Finally, we will return the distance. Okay, so this is the logic. Now we will see how to run the code. Okay, enter the number of vertices. Let me take the vertices as 5. Okay, and now let me enter the adjacency matrix. Okay, the graph which I showed you right now, I have written in the form of a vertex. So 0, 3, infinity, I will store it as 999, 7, 999, 3, 0, 4, 2, 999, 10, 999, 4, 0, 5, 6. This is the third row. Fourth row, 7, 2, 5, 0, 4. Okay. Fifth row, infinity, infinity, 640. 640. Okay. The source vertex is 1. Now, the shortest distance from 1 to 2 is 3. Shortest distance from 1 to 3 is 7. From 1 to 4, it is 5. And 1 to 5, it is 9. Okay. These are the values which we got in the trace just now. Okay. So, this is what our program is showing. So, this is about Dijkstra's algorithm. Okay.